This is Tej Ladani, and this is my data mining component 2 assignment, the presentation video. And in this presentation, I will show you what I did in Vika and how I did, and what are the results, and how can I do these things, and why I choose, and why this particular results. I will explain you everything in this video. Okay. And for the of requirement for our requirement, we have to clean the data set in our task 1. So in task 1 I already did these things. So I using of this data set, I will perform the task. I was performing the task in the Veka, and the in Veka, generally in Veka, this is the graphical user interface. So this is the easiest thing to the implementing the operations using of the different models, and the so we can generalize the our research. So these many things. And yes, in today's discuss I'll show you how I can use Vika software and compare two machine learning models, uh, KNN and linear regression. Yes, I use these two uh, the models, the KNN model and linear regression. as a, as a requirement of our assignment, we have to do a comparison of the two models between the KNN and the KNRS. And yes, using this software, we have to predict a profit, and for the market strategy decisions such as setting prices, managing stocks, and planning promotions. Traditionally, model like a linear regression are simple and easy to interpret. However, the KNN can detect nonlinear patterns and relationships that are often missed by the similar techniques. In this project, I wanted to find out which model is better for predicting profit in real world retail dataset, and how can this prediction help um, real-time businesses. So for the implementation, I have to do some importance column, like as a sales, quantity sold, discount, region, customer segment, and the product categories. So I took all these categories to in Vika, so I can implementing the target variable was a profit. So I use a mix of numerical and categorical features as a predictor. Before build the model, uh, we have to clean the data, but we have already cleaned data. So we have to check for outliers, encode categorical variables, and normalization numerical values, all the stuffs with all within our pre-processing model. And yes, this is the in pre-processing model I will do this all things. And first of all, my linear regression, yes, this is the linear regression. I selected feature based on the correlation, and checked for the multi-correlations using the variance in fashion factor. Numerical features were standardized to prevent scaling issues. This model assumes a linear relationship between predictor like sales or discount and the profit. Linear regression is useful because it's easy to explain, and business management can understand how each input affects the output just by looking and the coefficients. So in this linear regression is easy to implementable and easy to understand. So anyone can access these things, and determine the things, what are the best for the businesses for the growth purposes. And the second model is the KNN model. And in this KNN model, we have to predict the profit value of the five nearest neighbor using uh, Euclidean distance. This approach is powerful in retail business because it can adapt different customer segment, region, and product types. I tested multiple uh, k and values of k, and I found out that k is equal to 5 is gave me a best result, and I also used distance weighted averaging, which gives me more important closer neighbors. So this is k is equal to 5 as a KNN classifications. And if you talk about the model evolutions, the there are some values as a correlation coefficients, MAE, the root mean square, and the relative absolute error. This both are in the both models, and yes, for the validating purpose, I used 70% data is a training data and 30% is a testing data, and I used 10 fold cross validation to ensure model we are not in outfit model. So the in terms of result, the results are KNN had a higher correlations of 0.59, and while the linear regression is 0.666. And if we talk about the MAE value, the MAE value of the KNN model is a 56.75, and it was a closer to actual profit than the linear regression, which has a MAE value of 62.13. However, the linear regression had a lower RMSC value of 249.18 compared to um, KNN. The KNN has a 247.93, meaning it's handled extreme profit or loss value better. So, in simple meaning, the KNN is better at average predictions, and linear regression is better at handling extreme outliers. Yes. In terms of business insights for this model, the bot model relevant important patterns. Sales volume was a major driver of profit, and the moderate discount increase the profit, but heavy discounts hurt margins. It's in general terms, the discounts are more the against to the profits. If we providing more discount, then we get less profits. So in terms the situations are that, and the technology and furniture category had highest profit margin than office supplies, and corporate customer tended to generate more profit than home office and consumer segments. Regions like West performed better due to higher sale and optimized discounting. So we can say that can and could be also detect subtle relations like discount effect vary across product type, or how to profit changes by customer and type in different regions. And the practical applications and the recommendations is the canon used for real time decisions such as a price adjustment and inventory control, and it's work well for typical transactions. Yeah. And the linear regression is for strategical planning. It's interpretable so manager can understand which features matter most. So yeah, but I recommend to deploying both model together. In some cases the canon is best for the operational tool, and linear regression is explaining the why the behind those decisions in businesses. So if we do both model equally and at a one time, so it is more reliable to get a more profit, and in some cases of the profit margin that could be. So yeah, in conclusion, I would like to say the KNN is a perform the outperform to the linear regression in correlation and average errors, and making it better for profit forecasting in most retail cases. And linear regression also, the linear regression was faster, more interpretable, and better for extreme values. It can generate which is helpful for business reports and risk management. And in terms of together, this model help business forecast profit more accurately, adjust their pricing and product strategies, and ultimately makes a smarter data driven decision. Yeah, it is best decision to use a both model equally. And yes, and this is the both model interpretable predictability. And yeah, I can show you the graph representation of the uh, KNN line graph is the actual value versus the predicted value. The the blue lines are shows the actual value, and the orange line shows that predicted value. As we can see, this is the KNN line graph, and the next one is to be a linear regression graph. So this is the same as a Canon as a graphical representation, but having a different results because of the both are not performing same. So this is the difference. Yes, and yes, that's all. This is my the representation, and I hope you get all these things. And if you have any question, I am happy to answer you. And yeah, this is the my entire representation, and I will submitted my video link in end of the report, and also in video uploaded in the different module. And okay, thank you very much, sir. Yeah, bye bye.